Exercise 12G, question 2G. We're asked in this question to find out when the function f of x is a decreasing function. And you'll notice I've written in red there that the function only exists for x values greater than 0. And if you think about it, of course, if we're dealing only with real numbers, that's true. If x was a negative value, for example, -1, then you would have the root of a negative number, which, unless we're working with imaginary and complex roots, then it wouldn't be valid. Furthermore, we can't define this at x equals 0 because if you look at the 9x to the power of -1/2, what that really looks like is 9 divided by the root of x, and 9 divided by the root of 0 is 9 divided by 0, which again is something that we couldn't calculate. So I've gone ahead and differentiated this, and the derivative was fairly easy to find, of course. And what I'm going to do now is I'm just going to manipulate this algebraically to make it more convenient to get to the final answer. And in fact, what I'm going to do is I'm going to factorise this. Now, if this is the first time you've seen it, it's going to look a little bit unusual. But just for a second, imagine that first term wasn't a half x to the -1/2. Just imagine it was a half x squared, and the second one was -9/2 x cubed, say. Then what we would do is we would pull out the factor of x with the lowest power, which would be x squared in that case, and we'd proceed as normal. And in fact, we'd also pull a factor of a half out. And in fact, we do exactly the same thing here. We look at the two powers and we decide which of the two powers is smaller. In this case, it's x to the power of -3/2. And we're going to pull that out as a factor as well as the half. So I'm going to do that directly, and what I'm going to end up with is the expression that you see here. Now, the first part of it might need a little bit of thought, but just imagine expanding the bracket back out again. And imagine that x to be x to the power of 1. So if we expanded it, what we'd end up with is a half x to the -3/2 times x to the 1, and we could add the powers together, and indeed you should see we would get a half x to the power of -1/2 as desired. The second part's very easy to see, of course, because if we multiply a half x to the -3/2 by -9, then we get the desired term directly. Okay, well, the next step is, I think, for me to write this down as a quotient, as you can see. And what I'm going to say now is that if f' of x is less than or equal to 0, the function is decreasing, which is what we're after. And if f' of x is greater than or equal to 0, then the function is increasing. Of course, as it happens, strictly speaking, at f' of x equals 0, it's where the function is stationary momentarily. Okay, what we actually do here is we look for critical values, and critical values are the points at which a function can change sign, how a function can change from being positive to negative. And they will happen if either the numerator is equal to 0 or if the denominator is equal to 0. And I'll spend a bit more time in class talking about precisely why that's the case. But in this case, what you can see is to get the numerator equal to 0, x would be equal to 9, and to get the denominator equal to 0, x, of course, would be 0. And so what I'm going to do is mark those points off on a number line, as you can see. Now, the first thing I'm going to say is we know that x cannot be less than 0 because f of x is not defined here. And now all we do is we take a test value, first of all between 0 to 9, and then a test value greater than 9, so each in these subdivisions of the domain, just to see if the function is increasing or decreasing. Choose a convenient value. I'm going to choose x equals 4 here. Substitute that in, and I end up with this conclusion. Now you'll notice that I actually didn't bother to evaluate f' of 4 for the simple reason I could clearly see that it was going to be negative, and hence I know that the derivative is negative between 0 and 9. You only have to take one test value, and if it's going to give you a negative value for that value, then for all other values it would also be negative as it happens. So I now know that the function is decreasing between 0 and 9. I'm going to go ahead and choose a value greater than 9 now, just to make sure it's not also decreasing here. And if I find the derivative f' of 16, then again I'm not going to bother evaluating because I can see directly that it will be positive, and hence the function will be increasing for this part of the domain. So I can now write the final answer. Between 0 and 9 the function is decreasing, and for x values greater than 9 the function will be increasing. Do draw the graph down on GeoGebra just to confirm that's true. Just one point to notice. I put x is less than or equal to 9 there. I could also have put x is less than 9 and said x is for greater than or equal to 9 the function is increasing. It doesn't really matter unless we're talking about functions which are strictly increasing or strictly decreasing, which we don't happen to do in this course. Okay, so have a look at that, have a think about it, and yeah, that's how I'd approach that problem.